Yesterday at home, you are welcome to another wonderful time on Schoolonair. And today in physics, we'll be talking about physics practical. You will recall that in the last time that we were in class, we were talking about how to record the measurements and scientific observation. You also take note of the fact that I made mention of the fact that it is important that in recording scientific observation that we need to be legible, that we need to be precise, that neatness of work is also of utmost importance. I also told you about the importance of the decimal places and the use of calculator as well as the 4-figure table. Today we will continue from where we stopped by talking about how to plot graph, how to plot scientific graph. You recall that I told you that in arranging our work of measurement, observation on the table, we have to be careful in ensuring that we use the same decimal places for what we have done. We also need to be careful that in arranging our work now, we must strictly follow the dictates of the examiner in terms of what we are supposed to do. And today now, how are we now going to transform our table, our physics table, and our table that we of measurement now into a graph? That's exactly what we'll be talking about today. But to start with now, you need to know that in order for you to plot graph, you need to draw the vertical and the horizontal axis on the graph sheet. The horizontal axis, which is representing the x-axis, or what we refer to as the abscissa, and then the vertical axis, which we refer to as the ordinates now, are very important in drawing graph because we are having two variables now. One is going to be represented on the vertical axis, which we refer to as the y-axis, while the other one will be represented on the horizontal axis, which we refer to as the x-axis. More so now, we must also note that before you even plot the graph at all, you must take note of the fact that your table will also give you an idea of the kind of graph you will draw. A graph that is having negative parameters. Whether it is on x-axis, you must know that there will be more space. Your graph is going to cut across to allocate or give chance for the negative parts of the record. And you have to take note of that. So if your y parameters, the parameters are going to be on y-axis, is showing some negative figures, then it means that you have to give space for that also. And you have to know this before you even start doing your work, before you start plotting anything on the graph, so that your work will not be messed up or be in a kind of disarray. So you have to draw the vertical and the horizontal axis on the graph sheet with HB pencil. You need to use HB pencil for neatness of work and for legibility. You must also label each axis with the appropriate variables and the units. It is not acceptable for you now to just draw your diagram, draw your graph without actually letting us know the parameters that is being allocated to that particular axis. If you are talking about t, then you must show t, and then of course, as a matter of fact now, you must let us know the units of that t. You must know the scale of the graph, and this one will go a long way now in explaining, in informing the examiner that you really know what you are talking about as it has to do with the question. So you have to label each axis with the appropriate variables and units. It is important that you label each unit with appropriate variables and the units, because it's only by plotting it and labeling with appropriate variables and units that we know what you are definitely talking about. And without doing this now, it will be difficult for us to know what you are talking about. Also, when we want to plot graph, we need to check the tabulated readings to know the lowest and the highest value of the two quantities to be put on the axis. This is very important. You know, I told you at the onset that when you look at the table that you have with you, and the table is going to show you the axis, what you are going is going to be allocated to the y-axis, and what is going to be allocated to the x-axis. It is also of importance for you to look at the figures. The figures, the highest and the lowest figure now. That will tell you the highest point that will be on that graph, and lowest point on that graph. That way now you have an idea of the minimum value that will be on the graph and the maximum value on the graph, and this will make it easier for you to actually arrange your work on the graph, knowing fully well that you cannot go below the maximum value nor go above the minimum value. So you can go above. The minimum value must be stipulated, while the maximum value must also be stipulated. And once you know those ones now, it is going to go a long way for you to know. So when you are now plotting your graph now, and you now see that the last figure, which is the maximum value, is not being allocated on the graph, you will quickly retrace your step and then know that your scale is already having problem. And then you can easily think of another scale to be used. But in case of math now, at times they actually give you the scale to be used. But in physics now, you may not be given scale. Actually, formulating the scale by yourself is one way for you to know the graph to be drawn, and that will go a long way in assisting you. So you have to check the tabulated readings to know the lowest and the highest value of the two quantities to be put on the axis. There are two quantities. One is going to be on the x-axis, while the other one will definitely be on the y-axis. And the relationship between them now is what the question is all about under examination condition. More so now, you have to, like I told you now, you have to scale each axis. You need to scale the axis. And so the idea of looking at the highest figure and the lowest figure is to assist you in scaling the axis. So you have to scale each axis. You have to start from 0. But there may be instances when the exam you may not actually need to start from 0. But starting from 0 now is a standard. So you have to start from 0 or from a number that is slightly below the lowest value. You have to start from a number that is slightly below the lowest value. Why? So that there will be allocation for the lowest value on your graph, so that we can easily see the lowest value on your graph. But there may be instances now where we may draw a graph that lowest value actually may start. When you look at the length, the size of the graph sheet, and you look at the kind of figures that you have, and you look at the closeness of those figures to each other, it will go a long way in letting you know how to arrange, how to rearrange, how to shuffle your work in order to ensure that you have a perfect and a well-organized work at the end of the day. So you have to scale each axis. You have to start from 0 if the chance is that you need to start from 0, or from a number that is slightly below the lowest value up to or slightly above the highest value, so that at least 2/3 of the page will be used. You cannot draw a graph that is going to end up being too small on the graph sheet. Neither can you draw a graph that will not be allocated, that the scale is too in such a way that it will be difficult for you to put it on the graph sheet. Or you are now using a scale that will be difficult, like you using a scale like 3.5 for 1 unit. So along the way now, if you now end up having something that is a figure that will be difficult now for you to input there now, then there will be a problem, because there will be figures, or there may be figures. That's the essence of checking those figures at the onset, to have an idea on how to arrange those figures on the graph sheet, thereby ensuring that your work will come out not only perfect but neat, and then in such a way that the examiner will actually give you the required marks for the question being answered. So you have to start the scaling of each axis from 0 if the procedure contains instruction to that effect, or intercept on any of the axes is required. There may be questions that will be based on the equation of straight line. You recall that the equation of straight line y is equals to ms plus c, where m is representing the slope and the c is representing the intercept. So in questions that ask you to determine the intercept, there may be an instruction that will lead you towards drawing a graph that has to start from 0, so that the point of intersect can easily be identified. So the questions, the instruction that you have been given will go a long way in telling you, in informing you on how to go about answering the question. So you have to start the scaling of each axis from 0 if the procedure contains instruction to that effect, or you are asked to determine the intercept. But definitely now, the graph may actually not pass through the origin, which is maybe your point O, may pass through one of those points, but the question may ask you to start from the 0. If you are asked under exam condition to do this, then definitely now you must actually abide by the instruction, and you need to actually start drawing your graph from the origin, which may be O. But to the contrary, if you are not asked, then of course you may need actually to use your own common sense in order to arrange your work, in order to adjust the figures you have been given, in order to arrange your work on the two axes for you to end up having a graph that will be acceptable. The graph that is taking note of all the figures that you have recorded. The graph that is showing whether, if you are having negative axis, is going to show the negative part of the x-axis, or the negative part of the y-axis, and the positive y-axis and the positive x-axis. The more reason why, under exam condition, you may even need to actually kind of sketch something small with your paper, without not up to scale. So that will give you an inkling of how to do your work. So that way now, that one will show you the maximum point, the minimum points, places where each individual points are supposed to be. And that way now, you can easily go ahead and do your work in a very acceptable form. Then there are some scales that we cannot use. You have to use scales like 1 centimeter to represent 1 unit. You know, it's ratio 1 to 1. We are representing scale 1 unit. Then you need to look at the graph that you are using. You must be able to see the arrangement of each holes on the graph sheet. It's very important for you to take note of that. So there is no fixed rule. It's not a rigid rule about this. The rule is that any scale you are going to use for physics practical exam must be the one that will obey all those instructions, all those guidelines and rules that we have mentioned earlier on. You cannot draw a graph that will be too small or a graph that will be too big that will not allocate, that will not be able to accommodate all the figures or the parameters that you have recorded. So you have to use scales like 1 centimeter to represent 1 unit. You can also use scale of 2 units or 2.5 units or 10 units as the case may be. But you have to be careful about using units or scales that has to do with that is having decimal places. Using scales that are with decimal places, you must be careful and you must be very good enough to look at those figures you arrive at the onset when you are taking your readings, so that you won't end up having one kind of problem or the other. But for very large numbers, you can also multiply by the appropriate power of 10. Like I was saying now, that if you're having 23,000, you can say it's 23 times 10 to the power 3. So if you're having those figures under the same column now, 23,000, 10,000, 15,000, you will see that all of them are 1,000 now. They are having 3 zeros at the end of the day now. So you can have a figure that can say, okay, times 10 to the power 3. So that way now, your scales now will take note of 23. If it's 23,000, if it's 10,000 now, it will be 10. If it's 40,000, it will be 40. So that way now, because obviously now, your scale cannot accommodate 40. If you are now saying 40,000, the whole holes there will be difficult. But if you are applying this standard form arrangement now, it will also go a long way in assisting you. So you have to use scales like 1 centimeter to represent 1 unit, 2 units, 2.5 units, or 10 units. For very large numbers, like I mentioned, you can multiply by the appropriate power of 10. Also, in doing all this now, we can also ensure that when we multiply by power of 10 now, like I told you, there is no way you will always do this now without actually not writing the units. The use of the unit now is always very important. Whether you are using standard form or not, you must be conversant with your unit. Your calculation must be well organized and neat and legible. There can't be any shortcut way or crude way of going about it. So we can never use odd scales like 1 centimeter to represent 3 units. We don't use that. We don't really use 1 centimeter to represent 3 units. So because we may end up having problem, assuming that we're having something like 3.35. So now you now start calculating, because you have to be calculating now. And there may be, your calculation now may not be accurate as the case may be. So most times now we avoid them. We avoid scales like 1 centimeter to represent 3 units, like using 6 units, 7 units to represent 1 centimeter, 8 units, 9 units, or any other value that is not easily divided into 5 parts. Because if you look at the holes now, 1 centimeter in some graph sheet, 1 centimeter may be, when you look at the 1 unit now, you may have 10 holes there. So if you're having 10 holes now, how are you now going to accommodate something like 3, like 6 along the way now? It must be something that when you divide into 5 parts now, if it is 10 holes, 10 holes now can be divided into 5 parts. You can go in it. But when you start now using odd figures, you are using 3, 7, you are using 9, it is going to lead you into a kind of problem along the way. Because at the end of the day now, there are some figures that may not fit into the graph that you are drawing, and this will not ensure that your work will come out well. So it is very important now that we have to avoid those units now. The unit that you use now must be in such a way that it will not lead you into trouble. You have to avoid those scales that cannot be divisible along the way. Like I said now, since 1 centimeter of the graph sheet is divided into 5 smaller parts, try to understand. You have to try to understand that what each of the smaller parts represents in the scale you are using before you start plotting. I hope you are going to take note of that. Let's look at that again. 1 centimeter of the graph is divided into 5 smaller parts. So if you are having holes, you are dividing 1 centimeter into 5 smaller parts. So you have to try to understand that what each of those smaller units represent in the scale is what you are going to use before you start plotting. You have to look at what you want to do. You can't just start plotting immediately. Say, okay, you just draw the graph and start placing those things there. You must ensure that you go through it without even writing anything on the graph sheet to check if the graph sheet will allocate your figures. And how do you know that? You just count them and see whether the largest figure can come in, and those figures that may be midway, that are neither too small nor too high, can actually fit into your graph sheet. If they cannot fit in, the graph may be in trouble, and then you will also be in trouble, because along the way now, at the point when you want to draw your graph, when you want to find the slope, when you want to determine some of those calculations that need to be done on the graph, the graph may not be accurate. And then the accuracy of your graph sheet now will be a problem for you as a result of the fact that you didn't take note of all those things that you need to take note of in drawing your graph now and ensuring that the work is well done. More also, now you have to put a cross X correctly on each plotted point. So if you are drawing, let's say now on the y-axis now, you have the x-axis, you are having 5 here, and the 5 here is 2 on the x-axis. You have to link them up. You use ruler, then you have to make sure that you use ruler now to actually see, to avoid errors that has to do with parallax. You have to make sure that you are steric with X in order for you to see, ensure that the points where the link, where the vertical line and the horizontal line meets now is the exact point where the graph needs to be. So this is how to go about our graph. Like I said now, like I made mention of it now, it's very important for you to ensure that the graph comes out in a very good and proper manner. So dear students at home, today now we have talked at length about how to plot graph. And like I told you now, plotting graph is not the first thing in physics practical. You have to actually take observation and readings. You have to ensure that the reading now will also flow in or fitting into your graph. You have to choose your scale wisely. You have to look at the instruction that are being given, because if you are given an instruction now that the graph must start from an origin, based on the fact that maybe they want to determine the intercept, you must know that if you are not starting from 0, let's say you are starting from 4, and then the intercept is like around 6. Of course, you have to be careful in saying that the 6 is intercept because you didn't start from the origin. So the students at home now, we have talked at length about this. But I believe we are going to continue on this next time we meet. And from me, have a wonderful day.